Folks, our guest speaker giving a speech titled Horticulture. It is rocket science from NASA, Dr. Giola Massa.
Hi, everybody. I am honored to be here today in front of you. This is awesome. What an amazing room we're in, too. So, my name is Giola Massa, and I'm a plant scientist at Kennedy Space Center. I work for NASA. And I got into this through FFA, because I was once where you are, and my ag teacher was an amazing person, as most of your ag teachers are, I think. And he found out about the research going on at NASA on plants for feeding the astronauts. And when I heard about that, I knew that was what I wanted to do. So a lot of study and a lot of stubbornness later, I actually got a job at NASA being able to grow food for the astronauts. And today I'm going to tell you about what we're doing, why it excited me so much, and hope to get some great questions from you at the end. So let's go. Okay, so this is an example of a meal on the International Space Station. And this isn't just any meal, this is a fancy meal. This is Thanksgiving dinner on the space station. It looks pretty different from your Thanksgivings, right? Almost all the food up there is thermostabilized, prepackaged in individual portions. It might be freeze-dried where you add water. It all is pretty good. It has to be good before they send it to space. It rates really highly on taste tests. But over time, that food can degrade. And it's not an issue for space station because we're sending new food up there all the time. But when we go to Mars, and we're going to Mars in your lifetime, the food might not provide all the nutrients and the quality that the astronauts need. And we certainly don't want astronauts not getting enough nutrition because they have important work to do. So we're looking at plants to supplement that packaged diet and to provide food. And right now, we're just looking at fresh produce, but in the future, we're going to look at other types of crops. But plants are amazing. And so while they're growing for food, there are going to be psychological benefits of having something green and growing when you're living in an environment where you can't go outside without a spacesuit or you'll die, okay? That's a pretty stressful place to live and work. So having that little piece of earth with you might be really important. And having good, tasty variety in your food can also be really psychologically important. But again, plants do other things. So at the same time that you're growing the plants for food, through the process of photosynthesis, plants are taking up the carbon dioxide that we're all breathing out right now, and they give off oxygen that we need to survive. And through the process of transpiration, plants take up water through their roots, and they give off completely pure water in the form of vapor that comes out of their leaves. So you could capture that water, you could condense it, and actually drink it. So plants have a lot of roles in space, and they're going to be important. Now, back in the 1950s, this picture was made. This was a Topps trading card. This was before we ever went to the moon. And this was what they thought farming on the moon might look like. And I can tell you it's probably not going to look like this. Okay, you probably won't have to wear a scuba suit and a leotard to take care of your plants, hopefully. We're probably not going to grow scary purple plants that look like they might eat you, because that's not very psychologically beneficial. And any agriculturalist knows that this is not an efficient way to do crop production with your plants, really widely spaced. And we're not going to grow in tall, transparent domes on the moon because there are a lot of hazards on the moon. There are dust that can abrade surfaces. There's micrometeorites that could impact and break the dome. But the biggest hazard on the moon is radiation. Our atmosphere on Earth protects us from radiation, but on the moon there's no atmosphere, so you have galactic cosmic radiation and solar particle events that would really hurt or kill the humans and the plants. This one is a little bit better. This is a depiction from the 60s of what Luna City might look like, okay? And here we start to see humans working on plants in a shirt sleeve environment, no scuba tanks or gas masks. They wear better clothes, which is good. And the planting density is a little bit better, and we even have some automation and robotics helping out with plant care, which is probably really realistic. But again, we're in this big glass dome on the surface. So I think it'll look a lot more like this depiction, where we have densely packed layers of plants inside a habitat with a really thick outer protective wall, because that'll protect from those hazards. And the plants are growing in the environment that the humans are living and working and sleeping and everything in, okay? And you have these plants under electric lights, just like we're doing in vertical farms on Earth right now in urban areas of the country and around the world. So I think this is starting to get more realistic for a longer term base on the moon, and it'll take us a while to get there. Earlier, we may have something like this. So this could be launched on a rocket. It could be a habitat that's launched on a rocket, and hooked to that a separate module that could be a greenhouse launched on a rocket to provide fresh produce for the astronauts. And we could have this on the moon or on Mars. So I think we'll probably get there at some point soon, and I'm really excited to help out with that. What kind of crops are we going to grow? Well, right now there's no way to cook anything on space station. They don't have an oven, they don't have a microwave. They have some hot water. Apparently, I just read they're sending up a cookie baking oven for one cookie at a time. But it'll be a while before we have larger ovens. So right now we're looking at crops that you grow and pick and eat fresh. Your salad crops and your herbs that you could add to that packaged diet and make some interesting variety, okay? But then later, we will add the staple crops. And if you have an oven or a microwave, sweet potatoes and white potatoes are great crops. You know, things like wheat and soybeans take a little more processing equipment. So you're going to have to bring in your milling machines and, you know, your tofu presses and, you know, all of the stuff, bread machines or pasta makers, that stuff's heavy. So that'll be a little farther downstream when we have a permanent base on the moon or Mars and we can afford to launch some of that heavy equipment. So we're going to build to more staple crops over time. But for now, we're just going to supplement that packaged diet. Right now, we're doing work on the International Space Station. So the ISS is our orbiting laboratory, and we have 6 people living and working up there almost all the time. Sometimes a few more, sometimes a few less. And we have them testing equipment for these future long-duration experiments, as well as conducting scientific research on how things work in space. One of the things that they're testing is this small growth chamber called Veggie. So Veggie is a very low-power growth chamber, and we have 2 Veggies on the space station, and this was when the first one was installed, and you can see what that environment looks like. It's all metal and plastic, cables everywhere. There's not anything green or growing until we put our Veggie up there. So you can imagine how having something green might feel in that environment when you haven't seen the sky or a tree or anything, and you've been up there for months at a time. What types of crops are we looking at for Veggie? Well, we're looking for things that germinate reliably, that grow rapidly, and they have to be kind of attractive because, you know, you're not going to grow very many plants, so you want them to look nice. We want things with low natural microbial levels on their leaves or their edible portions because it's hard to wash your produce in space. And we want things that are very palatable and very acceptable because if it doesn't taste good, it doesn't matter how nutritious it is, people might not eat it, right? But it has to have good nutrients as well. And so in the very first test of Veggie, we sent red romaine lettuce and zinnias. Now, zinnias aren't a food crop, but we sent those to demonstrate and see if flowering would work well in our growth system. Since then, we've had students like you, middle school students and high school students around the country helping us select crops. And we've sent 2 crops that students have selected through a program called Growing Beyond Earth. So especially teachers and students who are interested, there's some information here on the stage at the end of the talk. Come up and grab one and you can find out how you can help us select crops like the dragoon lettuce and the extra dwarf pak choi. So this video shows the second harvest of veggie and the very first one where astronauts were able to grow and eat the crops that they grow. So this was the red romaine lettuce, and that's astronaut Kjell Lindgren harvesting. Now, Kjell's a physician, and when he got to the space station, he said that veggie was his favorite experiment because he really enjoyed growing the plants. You can see it's a very challenging environment to work in. He's holding onto the floor with his feet under some straps, and he tries to put the leaf down, but it floats away if you don't hold on to it. So you've got to be thinking about things a little bit differently up there and be really aware. You know, when we sent the scissors up for him to cut those plants, they had to have their ends blunted off so they wouldn't float away and poke someone in the eye. So we had the astronauts, they harvested, they got to eat half the lettuce, and they did a toast, as one does, and they enjoyed it. They got to eat something fresh for the first time in months. This is Kimia Yue, Kjell Lindgren, and Scott Kelly. And Scott Kelly was our 1-year astronaut. And they made some speeches. And Scott talked about the logistical complexity of having people live and work in space for long periods of time, and the long supply chain that's needed, and how from Mars we have to be more self-sustainable with our food supply. And Kjell, who is a physician, talked about the contribution that the plants had to the small ecosystem of the ISS, and the benefits of eating fresh food, and how nice it was to see green growing things, that psychological benefit. Since then, we've had a number of other crops grown. We've added new techniques. So this was the same lettuce, but instead of growing it for a month and harvesting it, we had the astronauts do cut and come again. And this is astronaut Shayne Kimbrel doing one of the repeated harvests for this red romaine lettuce. This is astronaut Peggy Whitson when she grew the Chinese cabbage. So Peggy was a farm girl. She loved growing crops in space. She said, send more. I want to just grow a lot more. And she grew Chinese cabbage and did repetitive harvesting of that. She was amazing. She had everybody working on the space station so efficiently. She was just wonderful, wonderful to work with. She finished everything in half the time we scheduled. And then Scott Tingle had the second veggie and was able to grow mixed crops in both veggies, and we did staggered planting of these. So we had them offset slightly, and they were able to continuously harvest every couple of days so they could get a lot more food. We want to see how it will be in long durations when astronauts are regularly eating salad in space. And so this experiment allowed us to do that. More recently, when we grew the dragoon lettuce and some red Russian kale, some of our new candidate crops, we had astronauts comment on the scent of green growing things. You know, this was a smell that they hadn't smelled in so long, and they really, really appreciated that. And then we grew Wasabi Mustard, which is a spicy crop, and the extra dwarf pak choi. And you can see here the astronauts enjoying that with their meals. You know, they make things like lettuce wraps. And in the back there, Christina Cook, who's on space station right now, had just eaten a leaf of wasabi when this photo was taken. And it was pretty spicy, but she said it was excellent with the shrimp cocktail that they have on orbit. Right now on space station, an experiment is going on LED lighting and crop growth. And we're growing in both veggies with slightly different red to blue light ratios. And we're looking at the impact of that light on Mizuna mustard, how well it grows, how nutritious the plants are. So we're going to be bringing half the produce back for nutrient analysis. How delicious the plants are. We actually had the astronauts do official taste tests and evaluate the produce. And then we're going to look at the food safety of those plants and see if there are any difference from the light in the microbial content on the leaves. And this time we actually have the astronauts fill out a survey, a set of questionnaires about how growing plants make them feel. So we can get this human research. So we're really, really excited by this experiment. They harvested, this is a photo from the ground, but they just did 28 days and they did a harvest actually on Wednesday of this week. And we were watching from here while they live streamed the harvest. They're going to be doing multiple harvests, and we hope the last harvest will be on Thanksgiving Day so that they can have some fresh greens with their Thanksgiving dinner. So I'm going to end with this, which is a picture from Valentine's Day in 2016, when Scott Kelly made the first ever flower arrangement in space. And he asked if he could make a bouquet. He made this beautiful bouquet out of binder clips and duct tape, because you use what you've got, and then he took photos of it. This just shows that plants have a lot of roles in our lives, many we don't even always think about, but they fill a lot of niches for humanity, and they'll continue to do so no matter where we go. So I want you to know that with FFA and with agriculture, the sky is not the limit. So thank you for your attention. Yeah, can we do questions? Okay, you're gonna have to shout out because I'm not sure which direction to turn. And there's a microphone back here if you want to ask questions. Microphone.
There's one right behind you.
Yeah, great.
I'm curious how plants are affected by gravity, and do you guys have to provide artificial gravity when growing your plants?
That's a great question. So plants are incredible, right? They sense and respond to multiple stimuli every day, and they can't run away, so they sort of deal with all these stimuli. Outside, they deal with temperature, they deal with light, they deal with all of these different senses. You know, their roots deal with rocks in the soil. And so in space, without the stimulus of gravity telling roots to grow down and shoots to grow up, secondary stimuli become important. So for instance, plant shoots sense blue light, and that tells them which way to orient their shoot towards the light in phototropism. And so as long as we have blue light overhead, the plants grow up, and it works pretty well. But the challenge isn't the plants so much as the water. So water behaves very strangely in space, and water and air don't mix well. You need to watch some of the videos of astronauts playing with water in space, and you'll see what I'm talking about. And plant roots need water and oxygen. So getting that combination right has been our biggest challenge in space, and using artificial gravity, like rotating, could help with that.
We've got one over here by the Cargill booth.
Okay, Cargill booth. There you are. Okay, awesome.
I'm Austin Meyer from the Hallettsville FFA chapter in Texas.
Hi.
I was wondering, how are y'all fertilizing these plants up there?
Yeah, that's another great question. So right now, we're just testing this out, and we're sending a solid substrate and a controlled release polymer-coated fertilizer. And the astronauts are adding water, and slowly that fertilizer dissolves over time. But that's not a very sustainable approach to be sending solid substrate. The fertilizer's great, but what we need to do is more sustainable methods. So we're doing a lot of work on water and nutrient delivery so that we can come up with maybe a hydroponic approach or something like that that will be able to sustainably grow and harvest and then regrow plants in the future. And we also need to do a lot of work on composting and recovering nutrients from their inedible plant material so that we can reuse those so that we're not sending a lot of fertilizer to space. Great question.
Over here behind you.
I'm Nina from New York State Adirondack FFA chapter.
Great.
I have a question about how do plants grow faster or slower in space?
That's another great question. You guys are really good. Did you plan this ahead of time? So, you know, so far we're not seeing much difference, but again, it comes back to the physics. So if we don't have natural convection in space, so down here, what do I mean by that? Heat rises, right? You go up in a house that doesn't have air conditioning on, it's hotter upstairs than it is downstairs. Well, there's no up and down, so heat doesn't rise in space. Birthday candle in space, you see the flame on Earth, a birthday candle is kind of tall and pointy and yellow. In space, it's a little blue ball because you're limited by the rate of diffusion of oxygen to that flame, okay? And so getting those environmental conditions right for the plants, having fans or having the ability to move the water and the oxygen to the root zone is really hard. If we can get all of that right, the rate of growth is about the same. But if we can't get that right, then plants might be a little stressed in space, and maybe they're a little droughted or a little flooded, and they might grow a little slower. Okay, is that good? Okay.
Dr. Massa, thank you so much for all of your expertise. I'm sure everyone here was impressed by your stellar presentation in multiple ways.
Nice. Thank you.
So as a thank you, we actually have a gift for you. And typically, the Blue Room MCs actually deliver this gift on this person's behalf. But this gift was actually made by an FFA member, Coy Kroll, of the Mount Carmel FFA chapter.
Wow.
It's a cutting board that he made at his own
Thank
FFA
you,
internship.
Coy. That's beautiful. Thank you. Wow. I'm so honored. Thank you.
Thank you both so
That's
much, and we
gorgeous.
hope you appreciate the cutting board.
Thank you very much. Thank you all.
Let's give him one big round of applause.